Thanks, everybody. I just want to welcome you to today's ETC Study Hall presentation of Dave Cunningham and the Magic of the Source 4. I'm your host. I'm Ginger Swartz. I'm with the ETC Education Center. I'm going to hand it over to my coworker, Steve Terry, who's going to introduce this session.
Thank you, Ginger. I'd like to welcome everybody once again to the ETC Product Development Time Machine. Today we're going to set our clock to 1989 and go back for a deep dive with Dave Cunningham on the engineering details and project structure, the unique project structure that created the best-selling spotlight of all time, the ETC Source 4. Now, my friend and colleague of many years, Dave Cunningham, needs no introduction, but I'm going to briefly remind us of some context surrounding Dave. If we look back over the last 45 years in the worldwide lighting industry, Dave occupies a unique product development position. He has been the architect of multiple enduring new technologies that have had a huge effect on the way we do lighting. Some of these include the Strand Light Palette console, the Strand CD80 dimmer, and the implementation of dimmer per circuit systems, the ETC sensor dimmer, and the subject of our discussion today, the ETC Source 4 family of fixtures. So, without further ado, I'll turn the time machine controls over to Dave. Fasten your seatbelts. Here we go.
Thank you, Steve. All right. So today we'll be talking about how the Source 4 fixture was developed. And the room that we're in right now is particularly appropriate for this discussion because this was the original light lab where the Source 4 was designed and tested back in 1990. So what I've done is I've gone back to the development notes on the project and I've put together a number of slides. So we'll go through those and they're my physical notes from the project. Okay, so this is a timeline of the Source 4 development and also the products that led up to that development. In 1989, Entertech started a dimmer research project targeted for distributed dimming. That project evolved into the development of the HPL lamp and then eventually into the Source 4 fixture. In 1992, Entertech partnered with ETC to manufacture and sell the Source 4 fixture. Let's take a minute to go back and look at what set the stage for this development and also how Entertech was positioned to do that development. In 1975, I met Wally Russell, who was president of Strand Century. I eventually became vice president of R&D at Strand and developed a number of control consoles there, including multi-cue, micro-cue, light palette, and also the CD80 dimmer. What was important is that at Strand, I put together a very effective development group under Wally's mentorship, and that development group later became key to the development of Source 4. In 1982, when Wally Russell left Strand, I left shortly afterwards because it just wasn't very much fun to be there without Wally. And in 1984, started Entertech, which was a research and development group, completely independent of any manufacturer. And that group was composed primarily of former Strand R&D employees. That independence was key to the eventual development of Source 4. Initially, Entertech partnered with Colortran to develop a series of control consoles and dimmer products. That pushed Colortran into the #1 position in the lighting industry And as work started to taper down on the projects for ColorTran, Entertech went off and started a research project on dimming. That's what eventually led to Source 4. So it was unusual to do a research project like this, and I don't know if you had any comments on how unusual that was, Steve.
Yeah, I think, it really set the stage for a new kind of development. The luxury of that sort of development had not been with us in the entertainment lighting industry. Products were developed for specific manufacturers with specific goals and specific release dates, and that's how they were funded. This project was unique in that it started out without any of those goals or constraints. And we're going to see very clearly as Dave takes us through the project the results that had in how the project unfolded.
Okay. Now, this research would not have been possible if Entertech had not been able to self-fund it, and also if there had been any commercial pressure to come out with a product in a short period of time. This is the Entertech development team. This group was formed at Strand in the early 80s and later moved to Entertech in 1984, and shortly after. This group worked particularly well because it had been together for such a long period of time. This is me. I managed the group and the outside consultants and manufacturing partners. Also, I focused during the Source 4 development on the lamp, the infrared coatings, and the borosilicate glass reflector. This is Greg Esikoff, who was also a partner in Entertech and managed the mechanical design team. Greg worked on the shape of the reflector and kept track of the optics in the system. Mike Kiktavi, David Liu, and Ed Chavez designed the Source 4 fixture. Mike and Ed, in particular, developed the complex rotating barrel system and the focus mechanism, and Dave Liu designed the aesthetics for the Source 4. Stanley Wong and Danny Hyatt ran the light lab and managed all the testing of the fixture and the lamp. Renee Souza was the office manager and kept everything running at Entertech, and Wally Russell, who had been the president of Strand and my mentor, was an advisor on the project, and he did the market research. The group that developed the fixture was much broader than just the people at Entertech. There were also outside consulting groups and manufacturing partners. Aerospace Optics developed the software for reflector design and the photometric system. John Forkner designed the aspheric lenses. Tom Galtz of General Electric designed the faceting and the reflector. Osram Sylvania manufactured the HPL lamp. Bausch & Lomb, the IR coatings. Jeanette Glass, the borosilicate reflector. And AWI, the aspheric lenses. And Zonfon, the castings. This is a cross-section of the Source 4 fixture. This drawing shows all the key features of the product. And let's take a look at those one at a time. Probably the most important feature of the fixture was the proprietary HPL lamp. That gave the fixture its extremely high efficiency, and that lamp was patented and couldn't be used in other fixtures. The second feature is the borosilicate glass reflector with an infrared transmissive coating on that. That allowed the heat energy or infrared energy from the lamp to pass through the reflector and into the rear of the housing rather than forward in the fixture. What this did was preserve the gel life, the life of the shutters and patterns in the fixture. and also kept heat off of the audience. Off of the actors on stage. The Source 4 also had a single aspheric lens. Now, this was up until that time, fixtures had two plano-convex lenses, and the aspheric lens gave better imaging at the far field, and also reduced reflection losses that were inherent in two lenses rather than a single lens. The final feature of the Source 4 was the rotating barrel. This was the first fixture to have a mass-produced rotating barrel. That feature allowed the user to adjust the shutter cuts and also to adjust the orientation of the patterns. Now, Source 4 was successful not because of any one of these features, but because of all of them combined. This last timeline, this is all the individual elements that made up the Source 4 and the sequence in which they were developed. It began with the dimmer research, evolved into the development of the HPL lamp. Once an optical consulting firm was located, we began the reflector design. Once the optics had been proven on the Source 4 fixture, then we started the actual design of the fixture itself, the infrared coatings, the glass reflector, the aspheric lenses, and then finally in late 1991, Steve Terry came out to Entertech as representative production arts and looked at the prototype of the fixture, and then the relationship with ETC developed, and an agreement was signed in March of 1992, and then the Source 4 was introduced at LDI in November of 1992.
Just one point, Dave. While we're looking at this timeline, everybody should understand the breathtaking risk of a 3-year project at this point in time in our industry with actually no possibility of revenue until the very end of the project. We were talking about this a minute ago, that this was unheard of, but this timeline really puts it into perspective, I think.
Yep. Well, also interesting, you see in the timeline that when we were starting the project, we didn't know when or if any of these other elements were going to happen until over a year later. So we didn't even have any visibility for a product at that point. Okay, now let's go in and look at each one of these elements. As I've said, this started as a dimmer research project. Why did Entertech start a dimmer research project? Well, in 1989, I developed 16 control consoles at strength and color trend. And I was getting a little burnt out on that. There wasn't a lot more you could do with consoles at that time. We weren't ready for it, but the big remaining feature was integration of moving lights. But that was still early in the moving light period. So I looked at consoles. They were extremely expensive to develop. They had increasingly poor margins in the industry, and most of the revenue was being generated by the dimmers, but they just weren't very exciting, so everybody wanted to work on consoles. So continuing the cost reduction efforts that were made for CD80, which cut the cost of dimming in half, D192 at Colortran and ENR also at Colortran, I decided to start on a dimmer research project. The objective of this project was developing a small, low-cost distributed dimmer that would reside at the fixture. To achieve this cost, I felt the only way to get there was to reduce the power requirement from 2400 watts, which was the standard dimmer size, to 600 watts. And in order to make it a useful product, we needed to develop a fixture and a lamp that produced the same light as a 1,000-watt fixture with 600 watts of power. So that became the Source 4. This is a sketch of the distributed dimmer. In 1989, it was going to reside in the connector of the fixture. But by the time we got to the first meeting in Madison with ETC, this was the development schedule that was proposed. The whole focus of the project had changed from a distributed dimmer system to standalone products, including the high-efficiency lamp, the ellipsoidal fixture, which became Source 4, and the enhanced conventional dimming system, which became the sensor and the multiplexer. The low-cost distributed dimmer was pushed into phase 2 and never developed.
And just one comment here, Dave. This moment in time where you decided to abandon such a, I'll call it, grand system plan was probably integral to the success of the product, because what was originally conceived here would have required changing a great many things in the system all at once. And what we ended up with was a fixture that simply could be dropped into existing infrastructure. And that made it very, very easy to adopt for the industry.
Yep. Well, that's, you always start these things out with pie in the sky, and then at some point, if you do the right thing, you get back onto the ground. So, yeah. Okay, well, let's see. As I said, the HPL lamp then originated because of the requirement to reduce the power for this distributed dimmer that was actually never developed, but it did lead to the HPL lamp. In 1990, I began discussions with General Electric. General Electric was one of the major suppliers of lamps to the stage and studio industry, and they also were the leader in high-efficiency infrared reflective technology, which boosts the performance of quartz halogen lamps about 30%. So they seemed like the right company to go to. I eventually got access to Len Hogler and picked his brain. We had meetings all the time because he had no one else to talk to about this. So these are some of the notes from some of my meetings back in February and later in the year. And we talked about formulas I had come up for the design of the filament structure, what the different filament structures were, the gas fills for the lamp. There's just not too many people he could discuss this with, and so he was really excited to educate me about everything that I needed to know about lamp design. What was interesting was, up to this point, lamp manufacturers had always said they designed the lamps, and fixture manufacturers took what they got and designed a fixture around it. This was the first time that the lamp was coming from outside the industry. So that was a unique departure from the normal relationship between lamp manufacturers and fixture manufacturers.
I suspect as we go a little further down the trajectory here, GE didn't really understand what they were getting themselves into with you, Dave.
No, they didn't.
Right.
So this is some examples. I looked at dozens and dozens of filament structures because I didn't really know what I was doing. I just had to find my way there. The different gas fills at different voltages. These are a number of the different dimmer designs that I was considering with different amounts of phase control, allowing you to get down to as low as 40 volts. The lamp gets much more compact at low voltage. Unfortunately, the dimmer gets much more complex. And over here we have a couple of samples of lamp designs, a single filament, a dual filament, a 4-filament lamp. Pretty much I was looking at everything, but it did finally coalesce into a design. This is an example of how far out it got. This is a dual envelope lamp that was an early HPL design. It had 2 linear filaments inside 2 separate envelopes. This was done to take advantage of the infrared reflective technology, which required a long, narrow filament inside a small envelope. And let's say I'm glad we didn't do this lamp. By the time we got to the first meeting with GE, I had developed a specification and settled on 550 watts and 77 volts. So the HPL lamp was originally a 77 volt lamp to work with a half-wave dimmer. By later in that year, you see the final format of the HPL evolving. So at that time, November of 1990, I flew out to Nela Park to meet with GE. That was GE's headquarters, and Nela Park was a very famous place in the lighting industry. It was the first industrial park in the world. It was a giant campus. It had Thomas Edison written all over it, and all the breakthroughs in the lighting industry of the 20th century were done at Nela Park. The meeting with GE went fine up until we got to the discussion on the marketing, and GE had decided they wanted to sell the lamp for $30, which was twice the price of the FEL, and I said, that's going to be a problem. It will really inhibit the sales of the product. And so that was the first crisis point in the project. So I went back to Los Angeles, and then 2 weeks later I made calls to Sylvania, got through the sales people, and finally to their senior lamp designer Ray Fleming. Sylvania agreed to do the project with the restriction that we had to sell the lamp because they didn't know whether they could put it into their regular distribution system. So it was basically a custom lamp, and the arrangements was it was a 30-page contract with Sylvania because they're a large company, but I retained patent control. They only got a non-exclusive license, and a part of the agreement was that the lamp could not be sold for more than $19, which addressed the issue that had come up with GE. This is the purchase order to Sylvania, 40 lamps at $50 a piece. So now the entire project was dependent on a $2,000 purchase order that would take nearly a year to execute. This was the kind of risk that was involved in the project that certainly might have turned out differently. A very important decision at the end of 1990 was to make both a 115 volt and a 77 volt lamp. These are my notes on that subject, and this was an important decision because the 77 volt lamp could only be used in a system. A 115 volt lamp could be used with anybody's system. So this greatly broadened the potential for the Source 4 market. This is the actual schedule that I set up for Sylvania. They really enjoyed me micromanaging their project. Oh, they kind of enjoyed it actually. So, and I chased the lamp, the prototype lamps, through all of these different venues where they manufactured the parts. The sales offices were in Danvers, Connecticut. The filaments were designed and wound in Waldoboro, Maine. Then the filaments were sent down to Juarez, Mexico, assembled into a bridge. Then the bridge went back to Winchester for inspection. Then they were sent down to Winchester was where Ray Fleming was located. Then they went down to Fajardo, Puerto Rico for the gas fill and the envelope, and then back to Winchester for basing, and then to Los Angeles for us to test. This schedule we actually got the lamps in August of 1991, 1 month behind schedule, and they worked. Yay.
Yeah.
Okay. So what makes the HPL so efficient and what's unique about it? The key to the HPL is the 4 filaments that are only 9.5 millimeters long, located equidistant from the center of the lamp or its optical axis. Another part of the design which was unique was the diagonal crossover. What that did was bring in the high voltage on one corner of the square box, and it exited on the opposite corner. What that did was place the high voltage across the diagonal of the lamp, and that allowed about a 30% compression in the optical diameter of the lamp. The lamp was also, this is something I picked up from Len Hogler at GE. It had 100% krypton gas fill, which suppressed tungsten evaporation and allowed us to operate at a higher Kelvin temperature. It also had a pre-focus base, which wasn't used on the ellipsoidal, but was used on the PAR. And then we used the one standard thing out of the lighting catalog, which was the TP22 pins. That gave us a reliable and proven connection to the burner, so that was one part of the lamp we didn't have to worry about. Going on, why does this 4-filament structure work so well? Early in the project, I looked at the collection efficiency of different sizes of filaments inside of a 6-inch reflector. The FEL was the standard in the industry and used in all the Altman, the Strand, the Colortrans fixtures. It was 19 millimeters long, which is extremely long. That's almost an inch long. And it had about a 50% collection efficiency. I found by reducing the filament length to 9.5 millimeters, we were going to get about a 30 to 40% boost in performance and collection. And so that's what eventually led to the 4-filament design with 4 9.5 millimeter filaments. By the way, the name Source 4 comes from the 4-filament structure. The other feature of that 4-filament structure is we started looking at the CC8 filament. Now, the CC8 stands for coiled coil, and 8 stands for aligned with the optical axis. That's a coil that then is coiled around itself. We found that by placing this lamp on a rotating mount and putting a photocell, it was very crude setup. I think Stanley Wong ran the tests. We found that it had a very wide distribution, which put a lot of the light into the fixture rather than into the reflector. It turned out that the linear filament, the C8 filament, which just means a single coil, had a much narrower distribution. That's shown here in blue. This is the actual test that was run. The reason this occurred was that this CC8 filament with the wide open loops sprayed light everywhere. The tight linear coil was shaded by the adjacent coil, and it forced all the light to be emitted perpendicular to the coil. So this got the light where it needed to be, which was in the reflector. The last aspect of the HPL was all lamps made for Stage Studio were 120 volt lamps. Anybody in the lighting industry knows you don't get 120 volts out at the fixture. So you get a 1 volt loss across the SCR, you get up to 7 volts loss across the inductor, and then you get loss on the cable, so you can have 104 volts out at the lamp. So as a compromise, we designed, I set the voltage at 115 volts, which in most cases then gave you about an 8% boost out at the fixture.
And I'd just like to comment here, when we look at this now, it's obvious. You say, oh, of course, that makes perfect sense. Why didn't anyone do that before? Because nobody was building a specific lamp to work in a system. The lamp was being handed by the lamp manufacturer to the fixture manufacturer. So this concept of normalizing the filament at 115 volts, I mean, it was a brilliant move and now looks obvious, but it sure wasn't back then.
Yeah. And then let's see what this all adds up to. Taking the 360Q as a reference point, the source 4 has 188% the efficiency of the Altman 360Q. 42% of that came from the compact filament. 10% came from the collimation produced by the linear coil. 3% came from the gas fill. So you see most of the efficiency is coming from the lamp. And then you get a 9% boost because of the higher reflectivity of the infrared coating, and then 8% from the reflection losses that are not observed because of the single aspheric lens. So that's it for the lamp. The next step was once I was able to locate the right optical design firm, we started work on the reflector because that was the next critical component in the fixture. And obviously, by the middle of 1990, we were heading toward a fixture design, and work was tapering off on the dimmer. This is, for anybody who hasn't seen it, this is a page out of the Thomas Guide. We're in 1990. This is pre-internet and pre-Google. So this is how I found consultants and manufacturing partners. I highlighted all these companies that might be of interest, and I did contact them all, and none of them had really the right skill set. They were designing systems with 8 lenses in them for microscope optics or imaging optics. They just weren't familiar with a single lens and a single reflector. One of the engineers at Optics One referred me to an oddball little company called Aerospace Engineering down in San Juan Capistrano. You'll see that it's written over here in pencil in the right-hand column. Aerospace is the company that then we engaged to design the reflector design software, and also they designed a custom photometric system to test the fixture. They, in turn, referred me to somebody named John Fortner, again written in pencil here. John is the one who designed the aspheric lenses for the fixture. So we set up an agreement. It started out with with $1,000 purchase order, but this custom software that they developed for Source 4 and also the photometric system then founded Radiant Imaging, which became one of the major optical consulting firms in the industry. This is the prototype of the Source 4. You can see very elegant. We've got the lamp mounted on a back bracket, the reflector's mounted on a second bracket, and the gate aperture is mounted on a third, and the aspheric lens is mounted on the fourth. They're all on an optical rail for easy adjustment. This is the prototype that Steve saw at Entertech in late 1991. And in fact, this is the only Source 4 that existed until a few weeks before the show. I don't know if you remember seeing this, Steve.
I sure do. And I remember, I don't know if I made the phone calls while I was standing in the light lab, but shortly thereafter I made 2 phone calls. The first one was to my partner, John McGraw at Production Arts, to tell John to get the money pump going because we were about to replace all the ellipsoidals in our rental stock. The second call was to Fred Foster saying, Fred, you have to license this. I am looking at the next big thing in entertainment lighting, and you got to get a license to this product. And I think the rest was history. But, you know, it did not take much of a leap of faith to see the demonstration of this prototype sitting next to a 360Q with a 1,000 watt FEL lamp in it, outperforming it by what looked like twice as much light coming out the front of the fixture.
That's because we tweaked up the color temperature that made it look brighter.
Yeah, right.
But it put out about 20% more light, which was still very impressive. So moving on from this is the Radiant System pictures of the Altman 360Q and the Source 4. It produced about 9,400 lumens. Source 4 produced about 10,000. And this is the first test that showed us that we were getting what we expected. This had a 1,000 watt lamp. This had a 575, and we were getting about twice the efficiency. This was said go ahead with the project and start designing the fixture. There was a problem though. If I go back to this previous slide, you'll see in the field there's two distinct peaks here and a valley right in the center. This was a problem. Because of the 4 filament structure, it generated 4 hotspots in the far field. This would not have been an acceptable product. And this was a crisis, another crisis point in the project. I called up my friend at GE, Len Hogler. Even though they weren't working on the project, he referred me to their reflector guru at GE, who had been designing reflectors his whole life. He said, this is a faceting issue. So he wrote this little basic program that produced these beautiful high-resolution images made out of zeros and ones and asterisks, showed that the smooth reflector generated the 4 hotspots, and if he added faceting, the image became smooth. We then took this faceting and put it into the radiant imaging design software, and the problem was solved. Now that we had proven the optics of the Source 4 and we knew that it was going to work, we needed to build a package around it. So that's where we started work on the actual fixture design. We're now about a year into the project. This is my beautiful sketch of the Source 4. This is early 1991, and it in fact has all the elements that ended up in Source 4. It had the custom lamp, the glass reflector, the socket assembly that became the burner, the 120 millimeter A-sphere, the 3 lens positions, and the 4.5-inch gel frame. We were a little bit nervous because the 6-inch gel frame was the standard, and we were worried about people accepting that. We showed an adapter, but that was never developed because we figured people would like the fixture enough, regardless of the size of the gel frame. The next step was Wally Russell went out and did a market survey by talking to customers, which he knew through Strand, and this was of the theatrical fixture market. It clearly identified that Altman was selling most of the fixtures. They had about 2/3 of the market, and they had a net sale price of $120. Strand and Colortran had a little over 10% of the market with a much higher price because they only supplied those fixtures when they had a spec job. So this told us very clearly that Altman 360Q was our performance target and also our price target. Interestingly enough, in the notes that Wally wrote up for me is a suggestion to take a look at a 360-degree rotating shutter assembly. That later became a very key feature in the product. These are profile images of the 360Q and the Source 4. The 360Q really looked like a kind of a 1950s industrial design. It wasn't very elegant, but it did the job. Source 4 had at least a more modern design for 1990, thanks to Dave Liu. And this signaled that there was technological innovation inside of this fixture. Also, it had a much narrower front profile because of the 4.5-inch gel frame, and compared to the 6-inch gel frame of the 360Q.
I just have a story about the smaller size of the fixture. So in 1992, we had the Production Arts Christmas Party, which was an annual event of the entertainment lighting business in New York. And Gary Fales came from City Theatrical, came to that party, and he took one look at this fixture and he said to himself, wow, this means all the accessories that are out there in the field are going to be rendered obsolete. We're going to need new accessories for every rental shop. And he promptly went back to City Theatrical and started a business, a separate inside his business effort to make accessories for the Source 4. So the market resistance to changing frame size and gobo holder size was virtually zero because the performance of the fixture spoke for itself.
This is now that we had started on a reflector design. Now we needed to put a coating on it. So I started looking at coating options. These are some of the first choices that I looked at. Protected silver was about 98% reflectivity. Protected aluminum was about 90% reflectivity. All the other fixtures were using hydroformed Alzac reflectors, which had about an 87% reflectivity. So these seemed good choices. They were relatively inexpensive and higher performance than the other fixtures. The only problem is when we made the first aluminized reflector, it just fried gel in minutes. Let's say this was definitely a crisis point in the project. We didn't have a product. And here we are in the middle of 1991, a little less than a year away from when when the product was going to be introduced. It didn't work. So here we are. This is my list of what the heck do we do now. Hot mirror at the gate, that had very poor throughput because of the poor transmission of a hot mirror. Let's make a 6-inch aspheric lens, which couldn't be manufactured. Saturated dichroic filters, that wouldn't have gone over well with the industry that was used to using gels. And maybe we'll make an infrared lamp, go back to GE, that'll take 3 or 4 years. None of these were very good solutions, so the best solution was the dichroic coating, which had very high efficiency and was potentially a practical solution. So I contacted the optical coatings lab up in Santa Rosa. They were one of the leading coating manufacturers. The problem is we made the first reflectors, we got them in and tested them, and within a few hours, all the coating peeled off of the reflector. So that didn't start off very well. That was the last crisis point in the project. Fortunately, Bausch & Lomb, which is the sunglass manufacturer, they were able to make a dichroic coating, which operated at much higher temperatures a month later. And they were then the coating company that was selected for manufacturing the Source 4 reflectors. On to the next item. To use this infrared coating, then you needed a high temperature borosilicate reflector. Borosilicate is not an easy glass to manufacture, especially in a precision shape. And it's not easy to mount in the fixture because now we've got a piece of glass in the reflector instead of a hydroformed piece of aluminum. So the first thing I looked at was adapting lamp shapes, which already had existing molds. So this is Corning's Par 38. Fortunately, the Par 38 is only 4.5 inches in diameter. It wouldn't collect enough light. And the next size up, the Par 64, Par 56, were very, very shallow and wouldn't conform to the shape required. So then it's back to the Thomas Guide. So I made this list out of Thomas Guide of potential borosilicate molding companies. The obvious ones were Corning. Lancaster was also near Corning in Ohio, and GE again in Ohio. The problem with all of these companies was they used 12-cavity presses that ran 100,000 parts in 8 hours and had enormous tooling costs. They just weren't practical for making prototypes or even for the level of production that we were expecting. So I found this oddball company, Jeannette. Jeannette Shade and Novelty Company. Yes, they made lampshades.
You couldn't make this up, right?
Nope. And I was a little nervous, but they were cooperative. The reason they were able to do it was they had a single cavity hand press, and they had low enough labor costs that they could make the part reasonably inexpensively. So Jeannette sent me their sample pressing. It was a nut bowl. So this is the whole Source 4 is now dependent on a nut bowl, and I still have this nut bowl. I keep it as a candy dish for meetings. Fortunately, Jeannette was able to make the part, get us into production, and then when we got the volumes up, we went back to Lancaster and GE because we were running hundreds of thousands of parts. But there's a few things like this in the project that are, in retrospect, humorous, but they probably weren't at the time. The last element of the Source 4 was the aspheric lens. The aspheric lens was designed by John Forkner. John went through many iterations of this design, and eventually he came up with something that showed better performance than 2 plano-convex lenses. This has a sharper cutoff than you see with the spherical lenses, and it also had better far-field imaging. We made a single prototype of this for the 26 degree, and it worked, so that meant all of John's calculations were correct. And then now we needed to make them. So back to Thomas Guide. These were the people that made aspheric lenses, but the problem is none of them could make very large lenses. So only Dr. Optic in Germany and Electro Optic in Hong Kong could make 120 millimeter asphere. Dr. made the first prototypes, which proved the performance, but they were too expensive for production because of German labor rates. Electro Optics got the order. And interestingly, here is the first purchase order for the prototype lenses arriving 2 weeks before the LDI show. Wow. So there were some definite close calls on this project. Now to the last phase of the project. This is the partnership with ETC, which of course was key to the success of the Source 4. ETC was a relatively young company and wasn't manufacturing fixtures at the time. They were really a console company, and they had just purchased LMI for dimming. The partnership began, I think once I decided in discussions with Wally Russell that I didn't want to start a manufacturing company because I wanted to focus on R&D. I put out word through Ann Valentino to Fred that we had something to look at. I believe that someone contacted you, Steve, and came out to Entertech in late 1991.
Yep.
And then that eventually led to an agreement with ETC and to the introduction at LDI. This is some pages out of the contract with ETC. ETC got an exclusive license to make and sell the product. One of the main issues that Fred was concerned about when we were negotiating this agreement was that I wanted a minimum, there was a minimum requirement of 10,000 fixtures a year. That sounded like an awful lot. Let's say it turned out not to be much of a problem. The Source 4 was protected by 16 U.S. and foreign patents. The lamp itself was patented. The lamp in a fixture was patented. Now that was key because it didn't allow anyone else to use that lamp. The rotating barrel was patented. The aspheric lens was patented, and the long throw plastic lens was patented. And then later, this last patent was the wave lens on the Parnell. What's interesting is this is a patent that was filed in 1991, and nobody ever developed a competing fixture that performed as well as Source 4 in that 30-year period. The manufacturing cost and the pricing of Source 4 was also key to its success. Initially, ETC wanted to sell the fixture for around $171. That was closer to the strand and color trend price. I convinced Fred to go to a much lower price that was just 25% higher than the Altman 360Q, and $143, and we did that by trimming commissions, royalties, and margins, but it was the right decision.
So I just want to comment about that, because what happened in the New York rental market was really a good barometer of what was going to happen around the world. Once the design community saw this fixture, there was no going back, because the performance was so seductive. And then, coupled with the fact that you had basically a 25% difference between the $119 price of the 360Q and the $143 price of the Source 4, that allowed the rental companies, all of the rental companies, to acquire this fixture in very high volumes. I'm pretty sure that our first order for Source 4 at Production Arts was for 5,000 pieces. It took a while for us to get them because the fixture was on allocation for so long. You couldn't get what you wanted in deliveries. But the uptake and the transition from the older fixtures to Source 4 in the professional rental market was very, very fast.
The Source 4 was introduced at LDI in November 1992. Nobody knew this fixture was coming. Fortunately, we kept it really pretty quiet. The ETC booth was absolutely jammed through the entire show. This is a photo from the show itself. That's Greg Esikoff demoing the fixture. It's Danny Hyatt in the background showing somebody a lens tube, and that's me over in the corner talking to salespeople.
It's understandable if nobody recognizes you because there's hair off there.
I think that came off a year or two after and never went back on. At LDI, the Source 4 won Product of the Year award. When I received the award, I dedicated it to Wally Russell, who unfortunately had passed away just a few months before the show and never saw the success that he'd helped create here.
And when you think about that 1992 show, it's worth, from ETC's point of view, that was a show where the Obsession console, the sensor dimmer, and the Source 4 were introduced all at the same time. So that was created a rocket-like period of growth for ETC.
After 1992, the Source 4 family expanded to include the Junior, the Zoom, the Par, and the Parnell, and later on the Fresnel. Interestingly enough, all of these products, except for the Fresnel, were all planned back in 1990. And I would always look at a project and say, same thing with light palette. I envisioned a mini light palette next, and I had kind of a long-term plan for evolution of a product. And in this case, the filling out of the family was definitely helpful to broadening they all used the same lamp. That made inventory easy for all the for all the rental companies and the people using the fixture. This is a graph of the sales of Source 4. It did become the most successful entertainment lighting fixture ever. Sales of 240,000 in 2007. Sales began to decline after that because of the introduction of the Source 4 LED fixtures. Although even those LED fixtures used the lenses and lens tube and had some of the same look as the Source 4. There were an amazing 3.7 million fixtures sold as of this date. And that's it.
That's great. So I don't know about all of our viewers, but I thought I knew a lot about this story, but in working on this presentation with Dave, I realized I did not. And it's such I think, a fascinating and unique, not only the product, but the trajectory of the project and how it unfolded. Nothing like it has happened since in our industry. So, Ginger, what does our question window look like?
Sure. Yeah, we've gotten quite a few questions. And so Ellen White, who is a coworker here at ETC, has a question that's kind of been, it's one of those urban tales that we hear around ETC, and that is was the story about testing the glass reflector inside the fixture by letting it fall downstairs true?
Yes, that's true. That's Greg. That was Greg's test. I have a set of stairs here behind the house, and we had to roll it down the stairs 3 times to see if it worked. And that was a test. We were really concerned that glass reflector, lenses were pretty substantial, but that glass reflector, we could just picture getting your fixture with a whole pile of pieces inside of it. Wouldn't work very well like that.
Sure.
So yes, Greg rolled it down the back stairs 3 times.
I think you covered this, but we had a question about the why 4 filament segments, why not 5? Had you looked beyond 4 for them?
Yes, I looked at 5. In fact, the high voltage filament, I think, has, I think it's got 6. But yes, I looked at 5. It wasn't as easy to support the bridge. 4 turned out to be the right number. You could bring in the 2 side supports from each side, and then there was a glass bridge across the top. So that was the only practical structure. Yes, 5 would have been better, but as you add more than the optical diameter, it starts getting fatter. So the filament not only has to be short, it has to be skinny too. So as you add more filaments, it gets wider. So that was the right ratio.
And Dave, just so people really understand this, your comment about the diagonal wires at the base of the filament and the high voltage issue of the filament. Everyone should understand that in designing a filament, you can only make it so compact because of the voltage differences between the different parts of the filament. And so that was I imagine, Dave, correct me if I'm wrong, but a juggling act between the geometry of the filament and maintaining the required voltage clearances.
Yes, it's a very complex balancing, and the gas fill that you use to go to these better gas fills, the krypton and the xenon, they don't have the same dielectric standoff as nitrogen, which is the cheap gas. So as we start, you try to push up one performance, and you get then you run into the arcing problem. And let's say you get it all working, and then you test the heck out of it to make sure that it's reliable and that it works, and you have to have some safety margins there.
Which, by the way, I'll just digress for 1 second and say that Dave mentioned this briefly, that when Sylvania was manufacturing the lamp, they didn't want to sell the lamp through their normal channels, which meant that the ETC operation was all of a sudden in the lamp distribution business. And
boy, that was popular.
It was not popular. It was not popular because going into the fixture manufacturing business for the first time carried with it a whole number of problems. I get severely talked to by Dick Titus if I didn't mention the new job created at ETC by Source 4, generally known as the filing clerks. You say, well, what does that mean? That was the people required to file the castings so that they would fit together. So this move into fixture manufacturing was quite a severe shock to the system of ETC. Forget about being in the lamp distribution business, because those early lamps coming out of Sylvania required 100% incoming inspection to make sure that they were in the right parameters, the manufacturing specifications. So there was a lot of gearing up to get the Source 4 to volume manufacturing.
Yeah, the whole lamp thing was very unpopular because you had an expendable basically, and ETC was not in the business of expendables.
Right. And there are collector's item boxes around where you'll actually see an HPL box with an ETC logo and printing on the outside. But David, tell about for just a minute how it went from being a proprietary lamp to a generally manufactured lamp with all the major lamp manufacturers as licensees.
The first pressure was, we've got a sole source Sylvania lamp here, and everybody was concerned about that. What if they decide not to make it? So I had already started discussions with Ushio in Japan, and I kept the license non-exclusive so I could bring in other manufacturers. So Ushio was the next one to come in, and then the next pressure was Europe. If we were selling these in Europe, Sylvania wasn't a big company in Europe, and Ushio certainly wasn't either. So that's when General Electric came in, because they had worldwide distribution. So eventually everybody got on board, and I have to say that I appreciate the new marketing people at GE specifically said they were not going to challenge the patents. They had started out saying, we've been designing lamps for 100 years. There's nothing you've come up with that. And then they said, whoops, I guess what you did. So that was GE. And then finally, down at the tail end, I think 5 or 6 years into, Philips finally came in. They said, we've got to be part of this too. So everybody, and of course, what happened then was, with 4 companies competing for price, the price of the lamp went through the floor with down around $10 or $12. It was less than the FEL. So that just made the fixture very accessible and common then.
What else do we have, Ginger, on the question list?
Well, kind of continuing on the HPL discussion, what work had to go into was there a complete reimaging of it or re-engineering of it for the European market? Like what?
Well, because it's a high voltage lamp, it's got different spacing requirements. We started working on that right away because ETC wasn't big in the European market initially, but that was an immediate. ETC was just starting to move into Europe, and so that was. Everybody over there was saying, why can't we have this product? So yes, we immediately went into that, but Sylvania did the 240 volt lamp almost right away, and there ended up being about 20 versions of the lamp because Japan had 3 versions. There was long life, short life, and then there was a 115, there was a 120 for the television market. But nobody seemed to mind because they were just minor variations in the lamp design.
And Dave, talk about, at least in the North American market, what's the most popular HPL variant by a long shot?
Let's see. Well, it's 575 short life.
No, it's
or
long life. Yeah.
Life.
Although the folks at Osram corrected me recently on that, but for many years, the long life 575 was the weapon of choice because of all the source force being installed in price-sensitive applications.
Oh, right.
Where
Broadway used the short life and the high schools, small theaters wanted the lamp to last.
Exactly. Yeah.
When the project was initially being developed, before you're looking at joining with ETC or anything, did you always have entertainment lighting, or was there any thought to any other industries that this could be used in?
I was familiar with the architectural market, and that's where I thought it might go to a miniature fixture, because there weren't any good miniature fixtures at that time. But yes, that was the only other market that was considered. But let's say we were we were really busy dealing with the demand in the stage studio market. The fixtures did start showing up in restaurants pretty quickly, lobbies of hotels.
Absolutely.
So it was an architectural fixture to some degree.
We had one question about how many prototypes were made of the body. How many iterations did you have to go through?
We didn't go through it. Like I said, that prototype that you saw was the only fixture that existed, and we were just relying on our design ability to come up with that. That's part of the reason for the filing clerks, by the way. But for the show, for the LDI show, I ordered 100 castings, and we assembled them, no joke, in my garage, and hung them in there and ran live tests on them. This went on for about a month before the show. And then those lenses didn't come in until 2 weeks before the show. So I believe Stanley and Greg and Mike and myself were all building fixtures to ship off to Las Vegas. And so there were 100 first prototypes, but they all went to the show.
In the context of modern, quote unquote, modern product development at ETC that we've gotten used to, that statement is just
no lithography, no SLA models.
No.
Yeah, we did things differently then.
Yeah.
Just a little. Can you talk about the changes over the years to the 26 degree?
I don't know.
Well, didn't we have? Well, there's one variant that didn't use a single lens, right?
Yeah, the 36 degree.
Yeah.
36 degree. No matter what we did, the single lens still had a hot spot. It was because the position that the lens had to be and its focal length, it had to be in a certain position where it concentrated all the energy at the arbitrary gel position. So we could not get that a single lens to work and not burn gel. So then the 36 became a two-lens solution, but only for the purpose of not burning gel. So it had a condenser lens at up near the gate, and then a second lens down in the fixture. So maybe that's the reference. The 26 didn't change very much, and I always knew the 26 was the high volume fixture based on the market survey of the 360Q. That was the most popular fixture. About half the market was 26.
Given the advances in both imaging and non-imaging optics in the last 30 years, do you think that the efficiency of the optical train could be redesigned with any significant improvements, or is this as good as it could possibly get with an incandescent lens?
Oh, sure. If I did it again, it would definitely have pushed the incandescent envelope, but there wasn't much need to do it again at that point.
It's an interesting, I've worked on a number of projects in the last roughly 20 years with Dave, and invariably we got to a point in the current project where we'd look back at Source 4 and say, wow, we didn't really know much in those days, right? I mean, it is amazing how the level of engineering that went into that product that was durable over the life of the product. About the only significant upgrade that we did was to introduce a high definition series of lens tubes in the early to or mid 2000s. But yeah, I mean, I think if you were going to, and of course, we just finished two projects that are significant retrofits for the Source 4, which are the Source Forward white light product and the Source Forward color product, both LED retrofits. And it's interesting to work within the constraints of that optical system and say, okay, if you were going to do it again today, would you do exactly the same thing? Answer, probably not exactly the same thing. But since
it was pretty good.
Yeah, that's right. Yeah. And as people ask, are we doing any more tungsten development at ETC? And the answer is pretty much an unequivocal no. We are not.
Well, I remember some of these things like the faceting design. Tom Galtz, and this cost me a free dinner and a plane ticket for him and his wife. He flew out, and we had the prototype set up, and there was still some imaging artifacts there. He went over with a ruler and measured the size of the image on the wall, and then figured out how to change the size of the facet. And this just reminds me of the guys, on Apollo with slide rules.
Yeah.
They got there and they got back,
yeah.
on a pocket calculator worth of computing power.
Yeah.
Was there a specific inspiration for the style of the body?
That I'd have to ask Dave Liu and Greg. Dave Liu was very good with aesthetics, so we just said, show it to us. And of course, we do a sketch. He'd do a hand sketch. We didn't remember that we're using drafting boards. Sorry. So he'd do a hand sketch, and we'd look at it and say, that looks pretty good. and I'd show it to a few people, but that's as far as we went.
A couple questions about functional benefits of the casting using aluminum versus other materials.
Well, we considered plastic. I had a bad experience with plastic on the ENR dimmer.
I'm glad you brought that up.
Thank you, Steve. That's one of your, that and high velocity airflow on. We were a little hesitant of plastic, even though it would have been less expensive. But we chose the die cast because it was extremely rugged, kept everything in very precise positions, and we knew it was going to work. We were trying to minimize the number of risk factors in the project. We had enough. We were out on a limb enough on other elements to not take a chance with that portion of the fixture, and it made it very rugged and tour worthy, which was probably very important for its acceptance on Broadway.
Yeah, I mean, there were no special road boxes or storage requirements. The Altman 360Q came out of rental inventory, and the Source 4 went in, and that was it. So I think we were all worried about things like the glass reflector, right? And the fact that it had more finicky mechanisms than the 360Q, but it was an extremely reliable product.
There's a couple questions about competition for the Source 4. How did the market respond for the competition?
Very, very unhappily. Altman was, of course, devastated because they owned the market, and that's not a nice position to be in. It did create a great market for a secondary market for 360Qs, but Altman eventually came out about a year later, I think, with what they called the Shakespeare, and then they did infringe some of the patents. Because it's hard to do what the Source 4 does without infringing the patent, so it's a friendly industry among certain people. So I think I just talked to Robert, and we worked out a deal where they could do it under a low-cost license, but the fixture really wasn't a serious competitor to Source 4, and they ended up having to use a variation of the FEL lamp, HX600, I think. But the competition and then Strand and Colortran really didn't do anything. People tried every once in a while, but it just none of them ever took hold.
A wide variety of copies began to spring up from China, right? And came into both the European and the North American markets through distribution agreements of one kind or another. But often they were kind of pseudo Source 4s, like they looked like a Source 4 on the outside, but when you took them apart or looked at their performance, they were not equal. Obviously, later on, I mean, the fascinating thing is that the patent protection persisted just long enough that by the time the patents were expiring,
LEDs were here.
That's right. People's interest in a tungsten fixture was much lower, right? So they protected the product through its glory days.
Yeah, there had been some questions about the patents, and I think that does a good job answering.
Okay. Yeah, there was also a cohesion because the fixture was so popular with dealers in the United States. A lot of dealers just didn't want to cross ETC and handle a cheap knockoff. So there was the U.S. market never got much action in knockoff fixtures. There were more in Europe, but those weren't substantial either. It was pretty much had 80 or 90% of the U.S. market, I would say. I don't know. I'm just guessing at that number. But it was a good run.
Yes, it was. Yes, it was.
One question is kind of going along those lines. Are you surprised by how long the Source 4 has lasted and how popular?
Hell yes. I can speak to this because, Dave Linscomb, who's our vice president of marketing, and I had over 10 years, we had a conversation, which went like this. Aren't we going to see a quick cutoff in Source 4 sales at some point due to the emergence of LED fixtures? It should be a step function. And we kept waiting for it. And if you go back to the chart that Dave was showing us before, you can see where the step function occurred. But it was a incredibly long run.
Another question, how did the degrees of the lenses get decided?
Okay, that's an easy one. There was standard, Steve, you probably remember these numbers better than I do. There was the 6x9, 6x12. They're the Altman degrees.
6x16, 6x22. 4.5 by 6.5. That was the array, right?
So those were the industry standards. So I said, let's just pick those. There's kind of funny numbers when you convert them to field angles, but that's where they came from. They came from the Altman numbers,
which probably came from other numbers. Ellipsoidals were pretty much standard focal lengths for since they were introduced, certainly in the early 50s.
Was there a moment in the development that you realized just what you had? Like, this is revolutionary, or was it kind of at the end?
No, I don't think so. I think I always started these projects like, you have to be very skeptical of things, to do any kind of engineering, but I just said, let's do something and make a product. And I think I always believed that it was going to turn into something. That this is on the heels of having done all these control consoles that kind of took over and dominated the industry. So I kind of figured whatever I did would turn into something.
Any ideas on how many HPL lamps have been sold over the years, or is that just information that we don't?
No, I had the royalty reports from all the manufacturers. It was running I think about 2 million lamps a year.
Yeah, didn't we determine, Dave, that
half a lamp per fixture per year?
Yeah.
So it was about 1 million a year at the peak, and then of course some fixtures came out of retirement. So I think it was running about 1 million to 2 million lamps a year. So that's probably 40 or 50 million lamps.
I just we didn't touch on this point, but buried in the success of Source 4 was the power reduction from 1,000 watts to 575. That had all kinds of good benefits in terms of the fixture performance. But what was surprising to me, Dave, and I think to us at ETC, was that it never translated into a corresponding power handling reduction in the system. Smaller dimmers, smaller cables, etc. Right? People just said, "Oh, I need 20 amp dimmers," right? In the North American market. So, and about in 2006, we did a survey of what loads were connected to dimmers, and we surveyed a tremendous number of systems.
Not very much.
No, the overwhelming majority was 1 575 or 2 575 watt lamps. So.
Well, and especially because that's where the product came from, was a power reduction,
right,
designed to benefit the dimmers, and that part of it never happened.
Right. Okay, so I think we're at the end of our session here. I want to thank everybody. First of all, I want to thank Dave. Dave, really been fascinating working on it with you and listening to you lead us through it. And I want to thank all our participants for coming on board, and we hope you enjoyed our session today. So thank you very much.
All right. Thank you, everyone.